Watch this ice cube shatter and melt. While it is easy to describe this as a solid turning into a liquid, relying on what your eyes see is a reliable way to fail a chemistry exam. For the Cambridge IGCSE 0620 Paper 4, general descriptions of everyday changes do not earn marks. Instead, the exam requires you to explain these changes using the specific framework of kinetic particle theory. This phrase requires you to look past the surface and describe the mechanical behavior of particles as if they were individual moving spheres. To meet the examiner's requirements, every state of matter must be defined using three specific properties: separation, arrangement, and motion. The mark scheme is built around this exact vocabulary. Omitting one of these 3 points often results in a lost mark. Success in the exam comes from applying this rigid structural framework rather than describing matter based on intuition. This heating curve tracks how a substance changes as it absorbs energy. It provides a map of particle behavior from a solid to a gas. Notice the flat plateaus. Even though we are constantly adding heat to the system, there are specific points where the temperature stops rising. We will analyze this curve from left to right to see how particles behave at every slope and plateau. We begin at the first slope. This represents the solid state. In a solid, particle separation is minimal. They are tightly packed and touching. Their arrangement is highly structured, forming a repeating lattice. As for their motion, particles only vibrate about fixed positions. The upward angle of this slope shows that as we add thermal energy, the kinetic energy of the particles is increasing. This causes the particles to vibrate faster. A thermometer detects this increase in kinetic energy and records it as a rise in temperature. The macroscopic rigidity of a solid is a direct result of this microscopic lockdown of particles. Eventually, the curve levels off into a horizontal line. This is the melting point. If heat is still being added to the substance, we have to account for why the temperature is no longer rising. At this stage, the thermal energy is being redirected. It is no longer increasing particle speed, but used entirely to overcome the intermolecular forces holding the lattice together. Because this energy is changing the arrangement of the particles rather than their kinetic energy, the temperature remains constant. This establishes a rule for the graph. Slopes represent an increase in kinetic energy and speed, while plateaus represent energy used to overcome intermolecular forces. Once melted, the playhead moves up the second slope into the liquid state. The separation remains similar. Particles are still close and mostly touching. However, their arrangement is random, and they freely slide over each other. We then reach the second, longer horizontal plateau. This transition from liquid to gas is a point where many students lose marks by using imprecise definitions. The syllabus requires you to distinguish clearly between two different processes, boiling and evaporation. While both result in the formation of a gas, their physical requirements are different. Boiling occurs only at one specific, fixed temperature. It is also a bulk process happening throughout the liquid, forming bubbles that rise. Evaporation is different. It occurs at any temperature below boiling, strictly as a surface process where only top particles escape. After boiling is complete, we move up the final slope into the gaseous state. In a gas, particles are widely spaced apart. Their arrangement is totally random, and they move rapidly and freely in all directions. This widely spaced, high-speed configuration explains why gases can be compressed into smaller volumes or expand to fill a room. The entire journey across this graph shows how adding thermal energy progressively overcomes the forces that hold particles together. This gives us a complete view of how matter changes state. Remember that whenever you see the phrase kinetic particle theory, you must describe the substance in terms of its separation, arrangement, and motion. Upward slopes show changes in kinetic energy, while horizontal plateaus show changes in the arrangement of particles. Using this framework ensures your answers meet the specific requirements of the Paper 4 mark scheme. Now that you understand the theory, it is time to test your memory. Visit studybuddy.tech to take a diagnostic test on states of matter and download our free revision guides. Apply these 3 criteria to your next practice paper. Good luck with your revision, and I will see you in the next video.